So today we're going to be going through the column from 73 to 75. So this should be a relatively quick column. It deals mostly with limits. So without further ado, let's go ahead and jump into the first question, 73. Okay, so when we look at 73, we're given this following table, and we want to find what is the value as the limit as x approaches 0. So we're saying the limit as x approaches 0 of f of x. So as x gets closer and closer to 0, from both the left and the right, what is the limit? So let's take a look. The first thing about a limit is we know it has to approach the same number. So both these have to be moving in the same direction. Let's see, I go from 0.218 to 0.220, so I went up by 0.002. Over here I went from 0.230 to 0.228. I went down by 0.002. So, good, same direction. This looks like it's also symmetric. So on the right side I go from 0.228 to 0.226. I went down by 0.004. From here I went up by, looks like, from 0.220 to 0.222. Sorry, that's up by 0.22, up by 0.002. Here I went down by 0.002. Looks like it's pretty consistent as I go, which means that as I hit this, I should be directly in the middle. So directly in the middle of 0.222 and 0.226 is going to be 0.224. So we're going to say the limit is going to be 2.224. They're moving in the same direction towards the same number from both the left and the right at a consistent pace. So we're very safe to assume not only is it between these two, but it's exactly between these two. Cool. So that is number 73. Let's take a look at number 74. So let's actually zoom out just a little bit so we can see the whole thing. So 74, given the graph f of x, we want to find the values of x that this graph f of x is discontinuous. So let's look at part A. So discontinuous means there's either a hole, a jump, or a break in the graph. Sometimes it can also be an asymptote. So what we notice is the left part of the graph is a line going continually in that direction, and there's a hole removed from the graph. So I know points of discontinuity are going to be at points of discontinuity at x is equal to, and I'm going to make this as a set, okay, 0, comma. I also notice I have another jump right here. I go from this point way down here to what looks like an asymptote on that part of the graph. So this is at 1, 2, 3. And then from that part of the graph, it's continuous all the way on. So it's just going to be at 0 and at 3. Cool. 74A, 74B. We're asking a similar question. What is the limit as x approaches 3 of f of x? So just like the question we did previously, we want to find the limit as x approaches 3 of f of x. So that's going to be at 1, 2, at 3. Now, in order for there to be a limit, the graph has to be approaching the same value from the left and from the right. And what we see here is the graph from the left of x equals 3 looks like it's approaching the value of y equals -2. However, from the right of -3, this graph is curving up, up, up towards infinity. So they're not pointing at the same number, therefore there is no limit. So the limit does not exist. Perfect. So 74, part C, last one of this. What is the limit as x approaches 0 of f of x? So the limit as x approaches 0 of f of x. So again, we're going to perform that same analogy. At 0, I'm going to look at what the graph is doing from the left-hand side. It looks like it's approaching 0. And from the right-hand side, it is also approaching 0. And even though I can't plug in 0, they're approaching the same value, which means the limit of that graph is that value that they approach, 0. Boom. So that was 74C. Let's take a look at number 75. So given this graph, we're going to answer a few things. For what values of x is f of x discontinuous? And we have to choose one of these. So let's discuss what we're seeing here. At -2, let's take a look. At -2, our graph is up here on the right and way down here at the left. So I know A is a point of discontinuity. This may be a multiple select, so we're just going to go through each one of these. At a value of 3, 1, 2, 3, we notice the graph is discontinuous because there's a hole. We've taken that part of the graph out that goes from the left and from the right, and it removes down here, so the graph is moving along, jump, jump, and goes right back up. So at 3, this is also a point of discontinuity. So this is a multiple select. Okay. What values of x? So at -2 and 3. Oh, okay, never mind. I didn't read all the answer choices. So -2 and at 3. This is not an only. So that would be only at -2, only at -3. It's going to be at both of those. And D, no points of discontinuity. Well, we know that's false because I see the graph jump here and here. So I know it's not going to be D. The only answer that we're going to have is C. And just because I kind of butchered how we wrote that, I'll go ahead and box this up a few times. There we go. That's the obvious answer. Those 2 points. And there we go.